So with that said, let's take a look at the app that I made for that Markov chain problem. So this one is a little bit more involved, but it has essentially the same structure where we have a UI section, a server section, and then that final command to tie them together. Now for me, I needed an additional library called iGraph. In the app that I created, there is a section of it that draws a node graph related to the Markov chain. It's a visualization of the Markov chain situation that you as a user choose. In order to get that to draw, I needed this library called iGraph. So I load that in, I load in the Shiny library, and then we have the UI. Now, I had to think a little bit more about what I wanted the UI to look like, so you'll see a few changes here. But essentially, we have, again, a title panel, and then there's some text. Now, the text here has some H4 and P tags, and those are for a 4th level header and a paragraph. If you're familiar with HTML, that may look a little familiar. And so what we can do here is just write that out and then put the text inside. So those are really simple. Each one of these lines is followed by a comma, so we can stack those together. And then below that, I have a sidebar panel layout like we saw before. And then we have a variety of slider inputs. Now these are, there are more of them because I needed more inputs. In the default example, you just see one, but you can easily stack in a few of these. And I have the name of each of these, and then I have the text, and then I have the preset values that I wanted. You may notice that I have width in this one. And so in this layout, 12 is the maximum. So 4 is a proportion of that max value. And so the other portion of this will go to the main panel, and we'll see that in a little bit. So below the inputs, I have a line just to divide the inputs from the next section, which is the node graph. And I was able to add in a little bit of style here to control the color of the line that I wanted. So I just used this hex code AC, AC, AC to give it kind of a dark gray color. And that fits in a little bit better with the rest of the default shiny colors. Then we have the node graph. This is a plot output called nodes that I'm pulling in from the output in the server section. And then I can change the height a little bit. I will say it was a bit of a struggle to figure out how to render the iGraph output correctly at the size that I wanted, because by default it was taking up a very large amount of space. So I had to play with some settings to get it just right. And so I was doing some things like trying this div and then trying some different alignment and a few things. And I made myself a note here that these controls are linked to the par settings, which is where I was trying to play with the margins. But anyway, that's irrelevant now. The plot output here shows the node graph. Below that, we have another line, and then we have more text. And this is the settings summary that I wanted to include to just summarize the numbers that the user set in the sliders. So here we just have the table output. It's a different type of output that was not in the default app that was loaded. But you can render a table, and that's what I chose to do here. Then we have another line, and then below that we have an action button, which is one of the types of input that you can do. And I named it gamble button. It has the text gamble, and then you can even add an icon in here. And so taking advantage of that, I used some dice, and that seemed to make a lot of sense. I also added in a few style choices just to set the background color and border color to match the standard shiny color palette. So that is the end of the sidebar panel. And now we're into the main panel, which has a width of 8, which occupies the rest of that total 12. And then we have a few things here called fluid rows. So you may have remembered we had a fluid page, but now we have several fluid rows, each of which contains a few things. So in this first fluid row, we have 2 columns, and you'll notice they are width of 6 and 4. And the first one has a table output, and then the column next to it to the right. So this would be in the page, the upper right portion of the page. This contains a panel. It's called a well panel. It's just a simple gray rounded corner square. And that contains a header and a little bit of description text to explain what happens in that center column that we called output matrix. Then there's a line between the rows. And so the second fluid row, which again extends across the page, that also has two columns. And the left side is the gambler's matrix, which contains a one-hot vector describing how much money they have to start and the amounts of money. I've arranged it in a table, but the way that is stored is it's really a vector of the gambler values, and then I made it into a data frame so I could render that out as a table. But again, it's set up the same way here for that row. There's another line, and then we have the third fluid row, which has the result matrix, which is the result of multiple gambling rounds that are set by the user, and then more description. There's also another paragraph here with a little help for interpretation. So that ends the main panel, and then we have an end to the layout and an end to the whole page. Below that we have the server, and in here I have a few things that are reactive, some old comments here that are not being used, but we have one object here called observe, and I had a rule set here to prevent errors related to the money being the wrong value. So essentially, if you start with more money than you can gamble, or if you have the same amount of money that at the beginning that you can win, the game's already over, so there's no point to do that. So I did eventually update the sliders to help prevent this as well, so this could possibly be redundant, but this is essentially just a little section of logic to prevent users from selecting the wrong amount of money. Below that we have some reactives here for the inputs that the user has selected. So we have essentially the table here that will show everything that the user has selected. We have the minimum bet, the maximum bet, the probability of winning, which they set, the probability of losing, which is sort of the flip side of the probability of winning. It's 1 minus that. Then we have the number of gambles, which is chosen by the user. And here we have all of this information stored here, and it's put into a data frame. And then that values can be rendered out as a table. Then we have some calculations for the transition matrix. Now this is the matrix that contains some zeros, some ones, the probability of winning and the probability of losing distributed according to the way that the gambling chain works. That is, you can go from $1 to $2 to 3 to 4 to 5 to 6, but you cannot go from 6 to 5 because the game's already over if you get that much. And you can't go from 0 to 1 because you don't have any money for that. So you can't gamble with $0. So this transition matrix describes all of those pathways in a grid form. And this is the same thing that the node graph does, but that's more of a visual form. So here in the transition matrix, we have the probability of winning, which is taken from the input, the probability of losing, which is calculated from the probability of winning. Then, just to keep things easy and straightforward, I actually hard-coded these different matrix values. I'm sure there's a really clever way to set this up, but this just makes it easy to explain. So when you have the smallest number of values, the column right here, the first one, 1, 0, 0, that adds to 1. Then we have the probability of losing and probability of winning, that adds to 1. And then the final column, 0, 0, 1, sums to 1 as well. And what this describes is across the top, 0, 1, and $2, and then the row names would be 0, 1, and 2 as well. And so this is quite literally the transition matrix with these variables instead of the actual numbers. And it shows how you would go from 0 to itself. It shows how you could go from 1 to 0 when you lose. It shows how you can go from 1 to 2 when you win, etc. And so that is the matrix values 2. And then for 3, 4, 5, and 6, it's the same way. And you'll notice that there's a pattern in the way that the probabilities are listed in there. And then I have a little bit of logic here with an if-else chain, just to show that if the user chooses a particular value, then the matrix values that are used in other calculations will select from those matrices that I just showed you. So we just update the one that's used in the calculations, and then we can create the matrix that will be used with the matrix values, which is one of these, the input bet max, which is one of the variable names here, and then it's important that I'm using this by row equals true. So it actually reads in these matrix values by row. So with that said, we can update the row names and column names. I wanted to make sure that these were present on screen. So I updated that so that it's a sequence from 0, 1, 2, 3, 4, 5, 6, etc. And then finally we return that final matrix. Now the gambler matrix, which is that one hot vector showing how much money is available at the start. This is again one of these reactives. And here we initially start with creating a vector of the correct length with a value of 0. And then one of those vector elements is changed to a 1. So I just look for the correct position using this money init slider and then use that. And you'll notice that it's +1, and that's because of the indexing that's used. And then here we have the output vector, so we just return that MG vector, which is the gambler's matrix. The last thing here, we have a gamble action button, and this is an event reactive. So this type of tool is listening to find out when you click it. So in this case, we want it to be clicked and then run the gambling simulation with all of the input information that the user has selected with the sliders. So here we have as our function called gamble, we have a function that takes one matrix, a second matrix, and then n for the number of gambles. So you could gamble once, you could gamble 10 times, you could gamble 50 times, and I wanted to be able to include that here in this function. And then there's a loop. So for x in 1 up to the number n, which is here, we do the matrix multiplication step, and then we also store that output as the first matrix to update it. And then as it continues to loop through, it will update based on that. And then we have a couple of just simple throwaway names here. So A is a sequence, and then B here is the output matrix, the final output from the simulation. And then I stored both of those in a data frame, and this is just to draw it on screen so you can see it. And then the names I renamed to $sign and probabilities. And so that data frame is the final result containing the vector that I need to show. And then we just use that. And then below here is the function running, and we do that with the gambler's matrix as one of the inputs, the transition matrix as the other input, and the number of gambles taken from that slider input. So this is where that function runs, and it actually takes in all those different values as M1, M2, and N. Below that, we have the node graph. And this was a little tricky to figure out, but again, I'm using the iGraph tools to do this. So there's some old code here that I'm not using. But here I have a variable with the name nodes, and I'm pasting in the sequence 0 to the highest number, the bet max variable. I'm just going to scroll up really quickly. So the bet max variable here is the name that I had used for the winning balance. It's sort of the most you can get. So that goes from, I believe, $2, $2 to $6. So using that, we'll just scroll back down here. Using that, we can get this sequence of numbers. So we have 0, 1, 2, 3, 4, or whatever it is. And then those will become incorporated into this iGraph. So X is the same thing. It's just a sequence of those same numbers. And then Y is several zeros up to the number of the input bet max plus 1. So with that said, this information is going to be used to draw the node graph, and I have a series of if-else here. Again, if you have that really high number, 6, then the from nodes and the to nodes, which is the important information to draw arrows here, are these numbers, as you can see in these little vectors. And that changes for every other situation you might have. So if you have 6, 5, 4, 3, 2, you need to change that so that you draw the correct number of nodes. And I have that, again, hard-coded. Again, there's a way to do this, probably more compactly, but this is a nice way to see it and help visualize what's happening. Now, down here, we have to develop our node list for the iGraph function to do what it needs to do. And so we have a data frame of the nodes, which are the names. It's a string of characters, 0, 1, 2, 3, 4, 5, 6. And then we have our X and our Y, which is the values up here. Then we have the edge list, which is the connections between those elements. So the node list is which nodes are in the chart at all, and then the edge list describes which ones are connected to each other and how. Then we can do the graph from data frame function and take the vertices in the edge list, and we want these to use arrows and not just simple lines, so the value directed is set to true. And so that's just stored in A. And then some of what you see here in the next section is the result of me trying to get the arrows to do exactly what I wanted them to do. And part of the problem is the way that they're pointed. The 0 looping to itself, for example, the loop could be aimed down, to the left, to the right, any angle. And I wanted it to go straight out to the left. And I wanted the other loop at the very end to kick out to the right. So we can see I'm playing around with these angles here. And then there's a setting here for the margins. This was extremely sensitive, and I had to try a few things to get this to work. But eventually I was able to draw the node graph in a large enough way right in the area where I wanted it. But there's some other settings here for the font and the font size and different colors and things like that. But this is the plot command that will draw the node graph. And there's some other R commands here for the margins. Below that, we have the outputs. This is the render table that will draw the values set by the user from the sliders. Then we have the output matrix. The transition matrix here is what's being drawn. I know I used 2 different names for it here, but the transition matrix will be rendered as a table. And then we have the gambler's vector, which will be rendered. We have a data frame, and we're again using that render table to print that out. And then we finally have the result of the gambling simulation, again, as another table. And then down below that, we have the render plot for the node graph. And that's the end of the server. So we have the user interface, again, with the layout, and it's looking for the outputs. So the names of the outputs are in the user interface. Below that, we have the server, and that's where all of the logic takes place. And then these specific different outputs, render plot, render table, etc., those are used to create the actual outputs that go to the input. or the interface. The last thing here again is that shiny app line. This isn't something you really need to mess with, at least not for simple apps like this. And it just uses the name of the UI and the server, which are left alone. So that's how that works under the hood. I will run it for you here. If you want to see more about how it works, though, check out my previous video. But this is going to show you what that all looks like together. So again, we see the title, we see the text with the headers. These were H4 in the code. If you look in the code, you can see how to do an inline link. And then down here, we have the left panel that we did all the inputs in. The middle is the left side of multiple fluid rows, which are sort of, I'm trying to highlight it here with the mouse. And then the right side is composed of well panels, which contain some text. So again, the user can come over here and play with the different sliders and get those to move around. And then they can play with the rounds of gambling, the probability. And as you can see, the node graph here is changing as I manipulate these numbers. You can also see that the transition matrix is changing, and then the gambler vector length is changing as well. And so if you were to take a look at the gambler vector, we can max it out to 6 here, so there's 7 values, and then we can change the starting balance and watch that 1 move around. For a deeper explanation, go watch that other video. And then down below we have the setting summary and then the gamble button. So when this is clicked, it will take all of the information from the inputs and then produce a table of probabilities for each one of these dollar values. And here with the given settings, whatever they were, it's extremely likely that you will end up with $0. So in this case, you're more than likely to lose. There's a 1% chance that you might win the game, but very unlikely. And then over here we have some text to describe everything. So that's it for the under the hood look at Shiny apps and specifically the Gambler's Ruin Markov chain simulation that I presented in the last video. So again, if you haven't seen it, go check it out. It tells you more about what that means. I do talk a little bit about what Markov chains are and how they work. But I hope you enjoyed this and stay tuned for more content. Please like and subscribe if you enjoyed this video and have a great week. Thanks.